Yeah. Good morning, everyone, and welcome to our session today. Today, we first start our session by a presentation by some of the participants. Like we mentioned earlier, we would encourage participants also, if you have something to tell us about what you do, that would be interesting for everyone. And so we have today with us Ameya Deshpande and Shishir Deshmukh. Both of them are actually members of a group called Akash Mitra Mandal, which is located in Kalyan in Bombay, and it's a pioneer by amateur astronomers. And what they actually have is that they have organized weekly meetings, etc. Now, this whole group of Akash Mitra, they conducted a project of imaging and measuring angle of 60 double stars in the southern hemisphere using 4 different methods. Okay, and their paper was published in the Journal of Double Stars in January 2019. I'll share the link with you about the paper. And today we have a short presentation by Shishir and Ameya on the work they did. While the video is on, it's in the form of a video. So while the video is on, you are encouraged to put your questions on the chat window. And otherwise, once the video is over, we can have an open Q&A session where you can unmute yourself and you can ask the questions you'd like to, right? So we'll start off first with the video. And Shishir and Ameya, they're online today. So you can get to talk to them once you see the video. Okay. So we'll start with it as that. And so I will take this and so here's the video.
Hi, I am Shishir Deshmukh.
Hi, this is Ameya Deshpande.
We both are part of an institute called Akash Mitra Mandal Kalyan, which is situated in a suburb of Mumbai, and with an objective of popularization of astronomy and inducing young students to undertake some research-oriented activity so that they can contribute to scientific community in a better way.
We at Akash Mitras are working in the field of astronomy for more than 3 decades. Every Sunday, we meet to discuss various topics in the astronomy. For last 7 years, we are conducting basic astronomy course for youngsters and elders as well, and the course ends with a practical session.
We are also undertaking some observational projects, such as we have observed novae, we have observed variable stars, we have observed and measured double stars. And for last couple of years, we have been working on stellar occultations. Precisely speaking, stellar occultations by minor planets. And we have so far observed more than a dozen such events successfully. And we have submitted our data to International Occultation Timing Association, that is IOTA. So in the month of June, we observed the stellar occultation by a dwarf planet Pluto, and it was first of its kind from Indian soil. And we did this observation in collaboration with ARIES. ARIES, as you may be knowing, Aryabhatta Research Institute, and it is based at Nainital. And the Pluto's occultation was observed and measured from that location.
This is our attempt to introduce about this stellar occultations to the vast majority of people. So in this presentation we will begin with very basic, like what is an occultation, what are its advantages, etc. And at the end we will see an actual occultation video recorded and analyzed by the Akash Mitras. So let's begin this presentation.
As you know, there are literally hundreds and thousands of minor planets in the solar system. They are moving in their respective orbits around the sun. So as a result, what happens is that while orbiting around the sun, they come directly in the line of sight between the Earth and a distant star. So in such situation, an observer on the Earth may experience that the stellar light is blocked by that asteroid temporarily. So just as we see during a total solar eclipse that the shadow of the moon passing across the surface of the earth, the observer in that shadow experience the totality. Similarly, the passing asteroid blocks the starlight, and the shadow of the asteroid will experience that a star is temporarily blocked, or temporarily its light is reduced. So this is exactly what is called as a stellar occultation by asteroid. So literally there are thousands of minor planets moving in the night sky. So every night there are plenty of opportunities of occultation. But the real issue here is to predict the event beforehand. In this slide you can see a picture wherein a dense star field is shown and one asteroid is moving through it. And what you can observe is that despite of moving through dense star field, it hardly occults any star. And that's what makes this problem very difficult. So you can note that the precise position of the asteroid as well as this precise position of the stars must be known beforehand to predict the occultation event. So slight error in the position of asteroid or the star may lead to either the false alarm of an event, or missing of a genuine occultation event. So once an event is predicted, there remains still a task of projecting its path on the globe of the earth. And this is a very crucial task because observers all over the world will be gathering in that narrow strip of shadow to observe that event. However, a small uncertainty in the position of the asteroid may deflect this path to few tens of kilometers or even few hundred kilometers in some cases. So in this case, for a specific observer, that event can turn out to be a negative event despite of being right in the middle of the predicted path. So this is very important issue. The experts have taken enough efforts to predict the path. Now all amateurs need to do is to go there in the band of the shadow and observe the event and then report it. So the exact orbital position of any asteroid can be computed basis its orbital elements. There are minimum 6 orbital elements required to compute the precise orbit of asteroids. So this is the first and a primary requisite to compute an orbit. Secondly, basis this orbital elements, the position of that asteroid at any given point of time can be computed. This is required to check the possibility of any asteroidal occultation. So the precise position of the asteroid is required at any point of time. Thirdly, the accurate position of the star. As you know, there are many star catalogs, many survey telescopes. They are continuously taking photographs of different parts of the sky, and thereby they have made very precise stellar catalogs, such as earlier it was Hipparchus, then came to Mars, then Tycho, and nowadays Gaia. Gaia is a European Space Agency's mission, and which gives accurate positions of several million stars. So that provides the accurate position of the star. But mere position of the star is not going to suffice the purpose, because these stars are subject to their own motion in the space called proper motion. The proper motion is nothing but the motion of the stars seen on the sky vector from the viewpoint of the observer. So each star is subject to a proper motion. So unless and until you have a good understanding of the value of proper motion of that star, there is always very difficulty in predicting the exact position or exact coordinates of a star at any point of time. So the precise value of the proper motion of the target star must be known. Most often this value is in the order of few seconds or a fraction of second. But even that much value is very important, because a shift of the star's position with respect to that much value may lead this prediction to go for a toss. Once the exact position of the asteroid and precise location of the star is computed, and if the asteroid is going to occult the target star, then the last part of the prediction remains is the exact path of the shadow across the globe. This is very crucial because from observer's viewpoint, all the observers, those who are willing to observe that event, must know where the center line of that predicted path is and how far it is to north and south of the center line, because a small error in the position of the shadow path will lead to shift of the path to about few hundred kilometers even. So the typically an asteroid occultation event prediction includes the following points: the date and time of the event, preferably in universal time so that reporting will be easy, designation and accurate position of the star, then designation of the asteroid, magnitude of both occulted star and the asteroid, magnitude drop in the starlight, path of the shadow across the surface of the earth from where the occultation is predicted to be visible. So these are the main points of prediction which are very important from the viewpoint of observing that event. Now the important question: why to observe asteroid occultations? The asteroid lasting for few seconds. Observers typically need to travel for a few tens of kilometers and sometimes few hundreds of kilometers to observe such a transient event. Why to do this? There are plenty of reasons behind this. The foremost reason is it gives amateurs all over the world an opportunity to create some scientific data. Because professional astronomers cannot be all over the place at all the time, the amateurs have this excellent opportunity to provide some scientific output to professional astronomers. Observations of asteroid occultation events can provide a mean to correct the predictions and data reduction techniques. For example, an asteroid occultation event positively observed from few stations and missed by other observers due to shift in the path can help astronomers to refine its orbital solutions, which will help in predicting future events more accurately. Further, amateurs and few experts in the fields are developing various data reduction techniques to report their observations. There are quite a few softwares available now that can reduce data efficiently and write a report file in a matter of minutes. Two negative observations on either side of the positive events can delimit its size. Further, multiple observations of an event with good spatial resolution can provide a very good understanding of the asteroid with respect to its shape. There are three-dimensional models available in asteroids in DAMIT and ISAM database that can provide a good fit to the multiple observations of the same event. Not all asteroids are moving alone. There are many asteroids that are having one or more satellites. When such asteroids occult any star, there can be multiple drops in the magnitude of the star besides the primary eclipse. Those smaller drops before or after the event can be because of its satellites. Minor planets such as 22 Calliope, 87 Sylvia, 45 Eugenia are having one or more satellites. There is yet another important phenomenon that was discovered while observing occultations of distant solar system objects called Chariklo. Small drop in the magnitude of the target star was observed before and after the main event with almost the same duration. The most plausible reason behind those secondary events is attributed to the ring system around Chariklo. So in short, observations of occultation have given multiple benefits to the astronomical community, and amateurs are playing an important role in it. Occult Watcher is an important resource for occultation observers. It is free software that was developed by Risto Paulo. You can see in the slide that it gives various parameters of the event with an interactive map. However, one of the most important features of this Occult Watcher is that it can also help in coordinating observations of multiple observers. The user can declare his position with respect to the path of the shadow, and the same can be viewed by other observers who can spread across the width of the shadow in such a way that the collectively all observers can have a good spatial resolution. Well, this is a schematic diagram of ideally placed observers across the width of the shadow. For different observers, the event will appear different with respect to time, magnitude drop, and duration, etc. However, collectively, their observations will help deriving good estimates of the size of the asteroid. This is a fine example of what multiple observations can produce. A very good asteroid profile can be constructed using precisely timed observation. Each observation is called a chord that will run parallel to the motion of the asteroid. This profile also highlights the importance of the negative observations because it delimits the size of the asteroid. Although there has been a large concentration of minor planets in the main belt of asteroids, that is between the orbits of the Mars and Jupiter, these minor planets are literally spread across entire solar system. So apart from MBOs, that is main belt asteroids, there are centaurs between the orbits of Jupiter and Neptune, TNOs, that is trans-Neptunian objects beyond the orbit of Neptune, and KBOs, that is Kuiper belt objects far beyond the orbit of Neptune to about 50 AU from the Sun. Owing to their vast distances and small sizes, it is often very difficult to study them in detail. Most of these objects are well beyond the reach of the amateur telescopes. Space missions like New Horizons to study Pluto can be the best option to study these objects. But it is very evident that such missions are very costly and also time consuming. So the next best option to study them is to observe them while occulting a star. A successful observation of occultation event involving such objects can be very useful in knowing few things about these distant objects. However, having said all this, the predictions and observations of occultation involving such distant objects is far more difficult than normal occultation events. Orbital uncertainties, very small angular diameter, greater integration time are some of the issues involved in such events. There have been a series of failures of predictions and observations of these events. However, in the recent past, there have been a marked increase in the successful observations of such events, and the results achieved are very remarkable. Many distant objects are found to have satellites and even rings. A wider network with collaborative effort can result in more and more positive observations that will lead to better understanding of these distant worlds.
Here is a summary for all the methods using which occultation observations can be done. Some of these methods, such as eye and ear method, are prone to more errors. Amongst these, time-inserted video method is a highly recommended method by IOTA to observe the occultations. It tends to produce lesser errors than others. Let us see various steps and components required for this method one by one. The first requirement is to have a sensitive video camera. Our occultation team uses modified version of RunCam Night Eagle Pro called as Astro Edition. To give idea about its sensitivity, we usually observe occultation from the areas having limiting magnitude between 4 to 4.5 for naked eyes. Using our 8-inch Newtonian and RunCam at its prime focus, we could record occultation of 12th magnitude star at 30 frames per second. The RunCam itself has options to change brightness, contrast and zoom levels. It also has gain control, which is extremely useful while observing too bright or too faint stellar occultations. Along with that, RunCam has 4 different night shutter modes. Setting the higher night shutter mode is equivalent to increasing the exposure for each frame, which improves SNR but decreases time resolution. To record the video from RunCam or any other suitable video camera, IOTA recommends Capture software. The software has options related to visual enhancement, scheduling events, and much more. Apart from capture, there are other softwares as well which can be used for this purpose, such as Lemovie, SharpCap, etc. The primary requirement is that the software should not compress the data in such a way to compromise the input signal quality. The next requirement is to have precise time on each video frame. IoT recommends a device called Video Time Inserter, in short VTI, which has inbuilt GPS receiver. The device can provide accurate time up to tens of microseconds by syncing its internal clock with GPS clock. Since the device relies on GPS signals, it should be kept in open areas during occultation. To improve signal reception in closed areas, the device has facility to attach external antenna. The VTI accepts input from runcam, then it imprints precise GPS time on each video frame at particular location and outputs timestamped video frames, which then can be recorded by software mentioned previously. All this happens online while recording occultation. The VTI also helps in acquiring precise location of observation site, which is mandatory thing in post-processing when multiple setups are involved. Though VTI is recommended by IOTA, there are some softwares such as SharpCap which can provide timestamps on each video frame using computer's clock. This method is lesser accurate, and if one wants to use this method, before the observation begins, the observer should synchronize the system clock with NTP server. One thing should be noted that both runcam and VTI requires external DC power which can be provided by SMPS or batteries. Speaking about post-processing, the very basic thing one must do is to obtain a light curve of a star undergoing occultation. Light curve is nothing but an intensity versus time graph. IOTA recommends using Lemovie or Tangra for this purpose. These softwares have various options to estimate intensity across video frames and provide light curve values. Also, these softwares can automatically read timestamps imprinted by VTI on each video frame. Once a basic light curve is obtained using occultation time extraction, or in short OTE utility, we can obtain precise timings for disappearance and reappearance events. PyOTE is an occultation time extraction utility written in Python, and the equivalent to this ROTE is written in R language. If instead of VTI we are using any other timing method such as NTP with system clock, we should carefully provide start time, stop time and number of frames as input in OTE utility for correct predictions of disappearance and reappearance. Along with predicting disappearance and reappearance time, the OTE utilities provide other measurements such as confidence levels for disappearance and reappearance, magnitude drop estimations, signal to noise ratio, etc. After successfully observing and analyzing the occultation, one must submit the results to regional coordinator by carefully filling the report form provided by the IOTA. The form has various fields such as event details, observer details, and the analysis details. The form is prepared in Microsoft Excel and is very easy to fill out. Also, necessary instructions and recommended options are mentioned in the form in the separate sheet. Once an observer submits a duly filled form to local coordinator, the local coordinator does scrutiny for the submitted observation. Once the local coordinator finds the submitted observations in good shape, the observations are then updated in centralized database. The centralized database can be accessed using another useful software called Occult. It maintains all the observation data such as event details, observation information, analysis result, etc. Occult also has tools to further analyze multi-chord occultations to obtain asteroid profile. Along with that, it also has lot of other options such as listing the current event predictions, historical events, obtaining 3D profiles for asteroid from online sources such as ISAM to name few. Now let us summarize time inserted video method. Observer should use a sensitive video camera to record occultation video. While recording, timestamps should be made available on video frames either by using IOTA recommended VTI or by lesser accurate NTP method. From the recorded video, observer must extract light curve for the star undergoing occultation, followed by precise disappearance and reappearance extraction using OTE utility. All the analysis details along with observer details must be filled in submission form carefully, and the duly filled form should be submitted to the local coordinator. Let's see how an actual stellar occultation can look. The following video clip is of an occultation by minor planet 894 Erda occurred on 2nd February 2020. A team of Akash Mitras recorded this event using RunCam and VTI setup attached to an 8-inch Newtonian telescope. In the video clip, when you see a star field, do observe the disappearance and reappearance of a star marked with red markers, which is of course because of 894 Erda occulting that star. Followed by that, you will see a light curve analysis done in PyOTA. So, let's play the video clip.
Lastly, but most importantly, we really thank to Dr. Najam and Dr. Priya for giving us this opportunity to interact with this audience. Thank you very much, madam.
Thank you very much. We really appreciate this.
Thank you so much, Shishir and Ameya.
Thank you for participating. Thank you for motivate everyone. And your experience is very important for all.
Yeah, and actually it's very impressive that, I mean, I also started as a student, amateur, astronomer, etc. But the idea is like what I can see in your work that, things have been done in an organized way, right? So that it's not just looking up and saying how beautiful, how good, but people have to learn that, one has to do organized work, and that can actually lead to, strong results, good results. So that's very good work. I'm very impressed. Very good. Please, participants, you all can ask questions, or if somebody wants to ask in the chat window, or you can unmute yourself and ask. We have Shishir and Ameya both over here. So please do ask questions if you have any. And obviously, if any of you all have groups who want to set up things like this, I'm sure you can always get in touch with them. And, if you want further details. But if you have questions, that will be really nice. So let's start with some questions. Oh yeah, there's a lot of.
Fine.
And if you want to say something, why don't you all say something? What I'm going to do is I'm going to mute all because there's some background noise coming. And when you all individually talk, just unmute yourselves. Okay, so I'm unmuting everyone. Now you, okay. So now go ahead, unmute yourself, please. Shishir, you're muted. Yeah. Okay. Yeah.
Yeah. Am I audible now? Yeah.
Yes.
Yeah. Thank you, madam. Basically, this is a very vast topic, and we tried to cover as much as possible. But there is always few points that remain to be explained. So one important point which we would like to highlight, and we really understood that while doing these occultations, is that the occulting body, whether that occulting body is having any atmosphere or not, that can be easily found out from that light curve. And you must have noticed that in that video, that light curve of star occulted by Erda, there was a sheer drop shear drop of magnitude, and again the steep rise in the magnitude. So flatly it was reduced. The light came to zero, and then again it came to the normal light. But if what if that particular asteroid, which was occulting the star, is having some atmosphere? That is what we experienced in case of Pluto while observing the occultation by Pluto. We could clearly understood that star was gradually diminishing. The starlight was, and again while egress also, it was gradually coming up. So nice V-shaped light curve was seen while observing Pluto, because Pluto is having some atmosphere, whereas the all other asteroids that we observed, there was a sheer drop and there was no signature of atmosphere in the light curve. And one more small point that I would like to highlight, uh, uh, just as we know a lot of things about the asteroid as such, there are some events wherein the discovery of double stars were also made while observing the light or analyzing the light curve. Because if the star is a multiple system, and by visual appearance it is not resolving, despite of that, if the passing asteroid occurs that star, the companion of the star first, and then the main star, or otherwise vice versa, it shows a clear signature in the light curve. In the light curve, you won't see one drop only, but you will see multiple drops. So that signature is also very nice to see, and such discoveries were also made while observing occultation observations. So we really feel that when we came across this field, we found that there are so many observations from Japan, which is very geographically very small country in compared to India, and there are a lot of opportunities for Indian amateurs to work on this particular aspect, and particularly the vast expanse of Indian land. Uh, so latitudinal difference is huge. So we can have a really good spatial resolution of this passing asteroid's path. So collaborative observation would be a very nice idea. Recently, Jyotirvidya Parisanstha Pune, they are also observing such events, and IRDA event they also observed. Although we were not too far, because the strip itself was very narrow, but there were two stations from which that observation was reported to IOTA. So I request the people in the audience to take on the think about this activity. Thank you.
Okay. And I'll just clear it. Your faintest is you get about to 12th magnitude, right?
Yeah. 12.3. We faintest observation we did.
And it's in Bombay.
It was in no. Sometimes see, for this kind of observation, we need to go for even as long as Gujarat or even Rajasthan. We went in different rural parts of India. It all depends on where that path is passing through. But from Mumbai, in our observation site is near the suburb of Mumbai. So from that location, we can see a faintest star up to say 11.5. So still it is good. And that run camera that Ameya explained, it is very sensitive, because at 30 fps it is showing you a magnitude 12 star. So that is very sensitive object, is a camera.
I'm myself from Bombay, so when I was a student, we used to go to Wangidi.
Yeah. One group goes to Wangidi.
And I think Bharat Adur also has his thing over there.
Yes. It is in near.
Because otherwise in Bombay you won't get anything to see.
Yes. Now because we have been going to our observation sites for last 20-25 years, and there has been marked deterioration of sky quality. So, but that is beyond our control, of course.
That's right.
There is a question for you.
Yeah.
From Sanjam Barekar in the chat window, if you can see it. Where do I find new occultation happening in near future, or do they happen on regular basis? I mean, is there a listing website where they can find it?
Yes, definitely. We will put that link in the chat window. There is one site, one professional astronomer called Steve Preston, who makes the computation of forthcoming events. and a lot of forthcoming events are given. The listing of those events, not only just the listing, but also the path from where these observations are visible. Then all the parameters in the statistical in the text file, txt file, all the parameters of the event are given. And apart from that, the next best option is to download that free software called Occult Watcher. So Occult Watcher is a very good software that you can download. And if you initially you will have to give the uh, settings about your own site, your own where you are located, and then once you synchronize it, it gives you automatically. It will keep giving you the newer events with all the magnitude of the target star, magnitude of the asteroid. Of course, one more important thing is it is not necessary that you should see asteroid during such occultation. It is not at all necessary. What matters is the magnitude of the star. If that star is within your within the reach of your telescope, then only you will be able to see that occultation, because asteroid in most cases asteroid will be much fainter, but even if it is not visible, it is blocking the star, so that is what matters, and light curve will be produced by the star. So that is a good thing. We will put that list in the chat window, that
Yeah,
site of.
I have already written that.
Okay, great. Thanks.
Yeah,
Thanks.
thank you. Yeah.
Okay.
Can you
I
please
can.
tell what kind of telescope and other requirements an amateur to make such observations?
Okay, are you giving an answer or should I?
Okay, so it actually depends upon like till what magnitude you want to stretch. So, for example, with using our 8-inch telescope, as we said, we could observe till say 12th magnitude star. So, like any kind of an amateur telescope you can use. The only thing is there will be limit to the like till what magnitude you can observe the occultation. And apart from that, like you should have some kind of an automatic tracker as well, because before the actual occultation event occurs, like there like the identifying the star field and identifying the exact star which is going to occult in that star field, so those activities will like take up say an hour before the occultation. So to maintain your field properly, you should have some kind of a good tracker. In our institute we have this HAQ5 tracker. So like our setup is HAQ5 tracker plus the 8-inch Newtonian telescope, and of course the RunCam VTI setup. I hope this answers the question.
So I would say that initially this is a kind of an investment to get a automated tracker and a telescope and VTI and VTI and RunCam. But I think that's why we are saying that it is a collective activity. It's not a single man's task, because it involves a lot of things. So collectively, if you are associated with some amateur organization, or you are collectively having 4 or 5 friends, so they can invest some money in this setup, and you will have a very good results then. Or you can also try to get in touch with nearby observatory if it is there in your vicinity, because we did such thing. One event was observed from Kavalur Observatory, 300 Geraldina. You can see its video on the our YouTube channel. So that observatory, we requested them to observe that event, and they accepted our request from their director's discretion time, and they were kind enough to observe that event and send data to us. So such things you can try out.
Mhm.
The
Yeah.
name of the tracker is HEQ5. I may just put it in chat window. And the make is Skywatcher. Skywatcher is a make. So HEQ5 is a good tracker, very good tracker. We have been using this HEQ5 tracker for so many other things, and it has given us a very good results, very good results. We did all our double star observation, deep sky observation, our all other projects we did from using this tracker. We got it somewhere around 1 lakh rupees at that time, but but now it might be a little cheaper. But the thing is that it is having a capacity of taking a payload of say 11 to 12 kilograms. So you have to decide the weight of your tube, and accordingly you can use our 8-inch Newtonian telescope. It is handling it very efficiently.
So there are
Sh-
other variants also for this HAQ5. So like you can decide what weight capacity you want. So there are some higher capacities as well, like about 12 kg.
Shri Ramia, I would be very grateful if you could, write a list of the equipment you've bought and, give their approximate costs, website from where you bought it, so that people who are planning, they can accordingly check on their budget and stuff like that. I would like to say that in support that organized observations, like what you all are doing,
Yeah.
are necessary because in the scientific paradigm, if you want to actually show accurate observations and data, you're obviously dependent on your detector, your equipment. And agreed, that's a problem with funding, but there are ways to go about and get funding. So, like Shishir mentioned, if you just have like-minded friends, or you have an organization, or you have something. So, first of all, you need to know what is it that you want, what do you need, right? And then you can accordingly aim or target to match that budget and get that equipment. I would also like to say that, like what the work that Shishir and Ameya, like they've been doing, it can also be done for variable stars, right?
Yeah.
And most stars are variable. So actually, if you actually observe a star, see the light curve, you can always, observe it. Another there are very good specialized softwares, like there's a Wilson Devaney method. There are various methods of analyzing softwares. So if you have students and you already have data, students needn't be got to even get the data. They can, write Python codes to analyze the light curves and get the stuff off from your data. So different people in the organization can work at different levels. Somebody is handling the equipment, handling the observations, somebody is handling the money, somebody is handling the data, the coding, and getting the results. So depending upon your members, depending upon who is interested in what, see, the best thing is make people do what they like doing.
Right.
So if they do that, then you can effectively get results. So it requires a certain amount of organization, but I really congratulate you all for the way you all are doing it. That's very nice.
Thank
I
you.
would also
Thank you.
like people to pay their attention to, I've put it on the chat window, the American Variable Star Observatory, AAVSO. It's a very good organization which has very organized observations of variable stars. Stella Kafka recently gave a talk in the Ayuka SciPop.
Yeah.
So if you go to the Ayuka website, the SciPop film, you'll actually see, I think a week ago, or 1 or 2 weeks ago,
Yes.
Stella gave this talk. She's the director of the organization, and she gave it on this thing. And like mentioned earlier, obviously the group would like collaboration from all over the world, depending on the visibility of stars, the occultation paths, etc. So you can get in touch with AAVSO also. They even have some training tutorials. They could actually help you in how to this thing, and connect with people who are like-minded, because that makes your attempt much more, forceful and powerful if you have like-minded people with you, right? So
And another thing is also if you can collaborate and observe from two different
having this problem, yeah, okay.
one of us has to be quiet. Yeah, so if collaborate and observe the same from two or three different locations, then there will be okay, so
Yeah, so Shishir, Ameya, do you want to say something to wrap up, or?
Yeah, we will definitely consider your suggestion. It was a very good suggestion. We'll make a checklist of the required equipment along with their approximate cost and the source where they can be available, and definitely put it, send it to you by mail, maybe.
Yeah.
Uh,
Thanks. I'll put it up on the website
Yeah.
so that people interested can accordingly listen.
Sure, madam. Thank you very
Yeah.
much, madam.
Don't call me madam, please. I'm Priya. Okay. Yeah.
Thank you.
So
Thank you
thanks
very
a
much.
lot, everyone. Thanks, Shishir. Thanks, Ameya. And now we'll go on to our next thing for today. Do we have any more questions? Okay, Gitanjali. So, Gitanjali, probably for your particular equipment, etc., you'll have to actually check what is the right, setup, or what is the stuff you need. And you mentioned you're from St. Stephen's, right? So maybe some amount of support can come from the college itself, or from some sources like that. So you can check out, and I won't know exactly what equipment you'll need, but an ancient is a good telescope. Agreed, you'll have to probably move out of Delhi on weekends to observe, right? Because there may be some limitations. Yeah. So just give me a minute. I will put on the other presentation. So the next talk we have is on astrostatistics. We are going to have 3 sessions of that, but today you'll just have a short glimpse, and then